just out of interest, how many of you were not here last Monday? Cool. Okay, so I'll try to, if there are questions, just stop me in the middle. I'll try to fill in the gaps if it makes sense. Okay, so I'm really happy because we're really close by to release a 1.0 version of Foreman. And it turns out that Foreman 3-year-old birthday is turning up this tomorrow. So it's a good opportunity and very excited to be able to talk about it. Foreman basically, so what Foreman is about for those of you who have no idea. So the things that Foreman is trying to address are in the area of provisioning, configuration management, inventory activity reporting, and ideally an API or a console where you log into, use it, and get resources fully configured, ready to be consumed by users or something like that. So if you need to set up your own application, ideally there's a simple API call or a UI action that you take, and you get something that works really well, automated with no manual steps in between. So really, for those of you who saw the slides, excuse me, but basically what we talk about is all of the stuff that needs to happen before you can even install the system. If it's bare metal, there's a set of wrecking it up. If it's virtual, you have to get all of the credentials or whatever, getting up the user, the ability to set up the VM itself. If it's EC2, I don't know, all that kind of stuff. Everything that happens before, that needs to happen before, the actual configuration of the system after it's get the OS installation, the actual configuration of the system, and the never-ending story about seeing what's happening, whether the system is in the right state, whether it's in drift from your policy or things like that. So in a nutshell, Foreman architecture, so Foreman is a Rails application, has its own database and authentication via LDAP or Active Directory or internal accounts. Foreman knows how to communicate to various cloud services, for example, RevM, VMware EC2, OpenStack, and this is for instance or virtual machine creations, or we can do bare metal, and that usually happens through a set of proxies that Foreman uses. Foreman uses something called a smart proxy, which is a subset of Foreman, which basically delegates and export an API or allow use a RESTful API to consume things like DNS, DHCP, certificate management for Puppet, for example, and things like that. Also, Foreman architecture in an enterprise is designed to be a single Foreman server or a single instance of Foreman, and running multiple locations, running multiple data centers. That you get one view for your infrastructure. You can get control, and you can easily deploy systems across the world, no matter where they're located. And that usually happens via the smart proxy architecture. So I think it's best to start with a small demo. Now, demo usually have a tendency to break. So I have a small, YouTube video we can start with. And later on, let's see. Where we go? 1 second. So, 2 screens. So this is something that a community member actually, hold on. Where's my mouse? Come back. Sorry. So this is something that someone from the community did a while ago. In here, it's a 2 minutes video. In here we should be able, okay. Oh, why is it? Okay, maybe we don't do full screen, sorry. I think that should be good enough. So this screenshot shows how a new server, in this case a web server, it's probably too small to see. A web server gets created. The user basically defines a few simple attributes about what the system is, and you just go through the various steps here to show you options. But basically, he's creating a new VM, in this case on libvirt, and he deploys the VM. This case, it uses Pixie boot because it's libvirt, and it uses, in here is actually installing Debian. So foreman is basically cross distribution, cross platform, cross distribution. And this is the normal Debian installer in this case. But it works the same for Anaconda or for Jumpstart or SUSE and so on. Where what happened behind the scene very quickly, all of the things like DNS records and IP address management and all of that stuff kind of happened for you. A user don't really need to know in advance IP addresses. The system automatically allocates one for him, reserve it, things like that. And you can see here, this is actually a no VNC console. I don't know how many of you know, but this is VNC inside the browser, which makes it very nice for the users just to be able to see what's happening. It is text because the installation is in text mode, but you could just do graphic in here as well. So what happens here in this case, system OS gets installed, then we install Puppet. Using our templating engine, we can install whatever we want, but in this case we install Puppet, and then Puppet takes over, configure the system, and you eventually would get the system that you need to, whatever that is defined in Puppet's policy. Maybe I can skip another minute or a few more seconds, but at the end, after the installation is done, it just goes, he logged into the system, but he just goes to a browser, put in the new DNS name that was just created, and you just get, in this case, this is a application that runs on this web server, and it just works. So he got exactly the setup he needed for his machine deployment. Let me try and now try some real demo. So, any questions so far?
Good. Just that the Revan support is already there.
Yeah, let's do Revim deployment. It's really the same. So I'll go back to the host tab. I'll click on new machine. Let's call it foreman. I'll choose where I'm deploying. I have bare metal, libvirt, EC2, Ovid, VMware, and so on. I'll choose my local Ovid instance. I can choose here predefined roles, basically, what this system is. So let's just choose, I can choose database, web, or whatever I define for my own needs. I just put a web server. When choosing that role, a lot of things get populated according to the predefined behavior I would expect from this role. For example, Puppet classes or recipes get applied, Apache gets installed, I don't know, maybe monitoring, like I use Ganglia in this case, gets installed automatically because that's what I defined as a web server. Someone else could define something else and his own behavior could be added. And, you could add additionally more, maybe I want more Apache related stuff or something else. I could just say I want SSL or maybe the Webalizer service just included, and that will be installed as well. I have in here networks. This is where I'm going to deploy. The host group basically implies also a set of defaults. So here I have the domains I want to deploy on. I could use various domains. I could deploy on various VLAN, and also the IP address gets automatically assigned to me. So this IP address was suggested to me. It happens too fast, so you didn't see it happening, but basically it went to ask a smart proxy, tell me which IP address is currently not in use, don't have a reservation, not alive, and so on, and gave me back an address that I can use. Operating system, which kind of architecture we're going to use. We support all kind of different distributions, different architectures like Spark and x86, of course. And basically, where we're installing from, what would be the disk layout, all of the small details you need to take care when provisioning. Specifically for Ovid, we can choose, cluster, template, storage domain, whether it's bootable or not, whether to power on the machine or not, and so on. Parameters, there's various values that you get from various components. Let's say if this machine is in that domain, or this machine belongs to this operating system, it gets some attributes that later on can be consumed by foreman, by the instance, by Puppet. So you could use those to drive a configuration file or something like that in Puppet language. And eventually, when I click submit, I'm getting the same progress bar. You can see here all the steps: DNS, DHCP, DFTP. Everything just kind of happened now, and we can see what happens in the system, hopefully. And system is now booting. You can see what's, it doesn't PXE boot, so it downloads whatever this will start the installation. Ideally, the same process works for other things. So if I want to create an instance in EC2, the user more or less feels familiar. It feels more or less the same. Let's say Renault EC2. I have already configured an EC2 provider. I can show that in a minute. And I'm going to deploy it in EC2 West. And I could choose whatever I could choose the same web server again. You would notice that these things remain the same, but maybe some here, for example, in the network tab, I can't really configure anything from EC2. I could just configure where maybe the DNS domain. So I could create a DNS entry locally in my organization that points to EC2, for example. And in here, I have image management, so I have to predefine the images in another screen. But I could choose, assuming that I've assigned an image to an OS, I could just use that. And here you could see, the flavor, Stack Micro, save some money, availability zone, security groups, and so on. And this basically, from the user's point of view, this works the same. There's something wonderful. I created a bug. Great. Any reason why there? Okay, give me a second to figure out what is the problem. If not, then, I did the same thing just a minute before we started, but that's the way it is. We are very close to a new release, so good thing we find bugs before we release something. If not, then you'll trust me that normally it works. Yeah, I broke it. Maybe I can change something. See, maybe the web server I've broken.
Can you have a micro with 64-bit?
Yeah, you're right. That's exactly the problem. That's exactly the problem, and we don't show the error message correctly. Thank you. Thank you very much. So I'll do that again. Thank you. I'm guessing that's the problem. We just didn't reflect the error message correctly. Yeah, there you go. So in this case, we do it differently behind the scene how it works, but from the user point of view, it kind of works the same. We create the instance, we get the IP address of the instance, and then we have different provisioning methods based on the image. Currently, in this specific case, we just use SSH. So we create a key pair in EC2, and so on. Eventually, we drop a shell script, which is very similar to the Kickstart post section, and then the instance gets basically equivalently to how you install it via Kickstart. So roughly the same thing. You get some code, gets executed, loading Puppet, and then Puppet takes care from that point in time. Right. Questions? Sorry? Food is here. Break. Okay. So now we saw a bit of a demo. I want to go back and focus on a few different areas. Inventory. We can collect all the inventory, all of the facts that Puppet basically reported back to us. We can use them, we can search through them, we could use all kinds of things. So if it works, yeah. So we could. So first of all, we could just look at the facts. You know, we could just see them, and I could search for defined facts. Let's say I want maybe I'll use a bookmark that I already made, something that gives me back maybe my kernel version. So I see here all the systems I have with their kernel versions, and I could easily see graphs, for example, that what is my distribution of kernels in my systems. It's also possible to create custom facts. So in Puppet, you can basically create your own facts based on what you need. So I created, for example, I think a fact called RHN, for example, whether the system is registered to Red as network. So I could see here I just have maybe 4 systems that are really well, and you could just, this is my own kind of something I added to Puppet, and later on gets, so it's very useful for users to actually, create their own statistics. As we saw, we can create all kinds of, we can simply search by fact, search by value. There's a pretty extensive list of, extensive list of stuff you could search on. And basically the search is one of the most powerful things. With the autocompleter, it's probably one of the most powerful things in Foreman itself. So we could also use facts to drive permissions. So we have our bug model, and basically you can say someone can manage systems that has only this fact, or kind of, so even if I've created my own custom fact, I could say this guy can only manage systems that are registered or not registered, for example.
Could you search for some CPU parameters, for example?
If they're exposed as fact, then yes. I don't remember by heart which facts we have that are. By the way, excuse the latency. It's just because this instance is in Valve, so there's 200 millisecond latency here, round trip. But let's say if I click on C, maybe it's E for product name or physical processor. Let's see, what is the value here? You can get all of that. I don't know which kind of attributes you're looking for, but you could, get the processor attributes. You could get I think it's called product name. Yeah, that gives us what is the system, which system I'm running. So I don't know. There's plenty of things you could. Most of my systems like KVM and IBM and so on and so on. Another thing obviously Foreman does is to classify. Basically, this is one of the interfaces to Puppet, telling Puppet what should Puppet apply for any given node. So we have a system we've created that now Puppet starts executing. How does Puppet know what to do? So in this case, basically it goes to Foreman and it asks what to do, and what to do is basically what the association we just did before, where we saw the list of classes. And out of that, we basically can manage all of the complexity of Puppet, and we can add some logic on top. So we can add logic of environments, which basically means different content set of Puppet manifest. So you could have maybe a production and development, and in development you run your latest configuration that you try out. In production you run your stable environment that you don't want to change. So we could manage that as well. We can, as you saw, we can group our servers into roles, or you can make your own decision what the group represent. But you can group them. You can even nest groups. So I don't know if you saw, I had base and then /web server. So I have someone defining what is base, someone else define what is web server on top of base, and you can nest theoretically unlimitedly how many that we can do in terms of classification is provide values to parameters. So let's say I have a generic definition of a web server and I define what is the port. By default it will be 80, right? But if I want to be able to drive that and decide a different value based on a different condition, based on a given system or whatever, we can simply do it per system or per facts or per whatever criteria that we want and give a different value. This has a meaning in terms of Puppet that in one place you write the logic, how to manage a system, and there's a variable called Puppet or Apache port. And on the other hand, you have all of the logic outside of the Puppet domain of determining which value should that specific machine should be getting. And it's very important when you have a lot of tenants or a lot of complicated environment that information should not be shared. Or if you care about that, someone breaks into your Puppet master or whatever, things like that. We have the ability also to update many hosts as one, so we can create groups of hosts, do bulk operations, and so on. So we saw already the classification, and I'll show if anyone wants the bulk operation. The next important thing is actually reporting. So it's not enough to just provision a system. You want to make sure that after it's provisioned, it's actually working. So if I go back here, we had the Renault system, I think, and here is the Fedora web server that we created. It reported 9 minutes ago already, and you can see here all of the. This is probably the first time Puppet ran, so it did a lot of stuff. You can scroll all the way down, see basically there is no, or you could see that there were no errors, no warnings or errors. That means it was provisioning correctly, and basically we know what happened. The system is basically now ready. If we ask for the system state, it's all good. It's all green, kind of. Maybe the colors don't. This report here doesn't represent that it's green, but if we look at it on the, if we look at it here on the host list, we will see that this machine is active, but it's okay. That means it's actually ready to be consumed. Then you could trigger it via other APIs. You could, query foreman API and configure your load balancer, for example. Now add that system to the load balancer, or something like that. Basically, you see that Puppet successfully ran everything it was supposed to be doing. It's all good. Now the system can be consumed, or whatever.
Question. What happens if you SSH to that host and kill the Apache?
So Puppet runs based on your criteria, but by default the best practice is to run Puppet periodically, and then Puppet would start it again. So I can show if you want.
Okay, so how fast will this thing realize that it needs to run?
So this is not a monitoring framework. This basically is a Puppet, the ability to express what Puppet did and what's the output of a Puppet run. It could show you that Puppet hasn't been running it and there's a problem, or it could show you that 10 minutes ago what happened. Okay, it's not showing you now immediately. It's not a monitoring framework. It's just to show you that your configuration, in your configuration management domain, you're doing well. Your systems are configured according to what you expect them to be.
Okay, but can you schedule a Puppet run manually at least?
Yeah, sure. If I run it now, give me a second. Terminal. What was the system name? Renault. So if I sorry. Then the system obviously responds with DNS. We could change something. Let's say you said Apache. Yeah. Too hard. And if I run run, asks the server what it's supposed to be doing, and starts Apache. And if we go back to foreman and refresh this page, you would see that you can see it here, it's still active. And if you look at the last report, you can see all kind of notification message we saw there, and also the Apache service is now running. So, and also, I think you will get it when you look for reports or your dashboard, for example. If you look for what's going on, then you will see that one host was active. Maybe people care about that in terms of auditing. An enterprise might care that all of their systems are not touched during production time. So make sure that no one manually went in and changed. Or it offers some traceability, and also offers the administrator a peace of mind knowing that the system is the way it's supposed to be. Right. Any more questions? So we were here. So what reporting? So we have the dashboard we just saw. We saw the log of what Puppet did. We also have the ability to search. For example, find me all Apache related, or all service related, or all YUM related, or whatever it is that we want to look for. We also have an audit log, which is important to see what happened. In here you can see a few things that happen. Some of the things happen automatically. Some of the things happen by a user-triggered action. So we can see here that I have somewhere here created. Okay, so there are a few things that happen here in the middle, in between. Like my specific machine actually changed its IP address. So while we were demoing, I have Puppet running on my machine, and it reflects here 14 minutes ago. We can see we've created the EC2, and I've created also the Berno, or I assigned the Apache Webalizer class. So basically you can see here everything that happened. We can see who did what, and we can also click and see the history of anything here. You could see the history, for example, everything that happened with this machine. Maybe not so interesting, because just the IP address every time I move a DHCP changes. But if I search for something else, maybe say take an older host that I have, which is maybe this one. We can see exactly everything that the system did, like comment, or some point in time the MAC address changed, or I don't know, reprovisioned, and so on. So really you can see someone adds a class, it changes something, all that stuff. Basically it offers you traceability either by user or by resource that foreman managed. Yep.
Was there any reason why there is no search for this page?
You are in the show action of a given action. If we go back, you have search. So you could search here for.
No, but for the particular host, I would like maybe to search for some actions.
Okay. Patches are welcome. I'll show you the time record.
Or you can have more than one condition.
Yeah, you could also, if you really want to, like you could have here another, let's say you were saying you want a certain action maybe, then I would say an action equal or not equal, maybe update, or maybe just create. I want to know when the system was created, then you can see that a year ago, or exactly May 25th, that system was created. location X, production environment, and this type of host. You can create your own customized reports. Also alerting, we can alert via the API, not via the API, but we expose it via the API, so a lot of people use Foreman together with Nagios to, for example, ensure that, first of all, to configure Nagios. So whenever we add another system, there is an API call from Nagios saying, give me all systems. And then, automatically you can add more systems to be monitored and to remove them when they're gone. But also you can query, get, what is the status of the system, what was the last report, was the last report, just show you. So if I go to a specific host, for example, and I click on this host last report, I can normally also ask for every page in JSON, for example, and I would get here, not so trivial to see, but you would see here exactly the status, and there's also some nice keywords saying here, for example, summary modified. This is an active host, something happened. You can get, and you can drive a lot of things from this kind of an API to automate your monitoring, to automate your backup, to automate, whatever you want when there's cross-node communication that needs to happen. A lot of people actually use this API from within Puppet. So an example would be a database server needs to know which clients are allowed to access that database, so they can configure, access lists based on that. You can ask for another system IP address. You can do all kinds of stuff like that. So behind the scenes, a few things that happen or can be happen. We do the whole CA management is kind of transparent. CA is where a certificate was issued to the system and all that stuff kind of happened behind the scene. We could trigger, so we don't have Foreman doesn't have an agent. It actually we tried by definition not to have an agent, so we can still trigger Puppet runs if Puppet is supporting that. We have quite a lot of integrations like Puppet Doc. Obviously, we have the ability to import your Puppet environment into Foreman. I can show that. So if you have a new Foreman installation on top of an existing Puppet infrastructure, you can immediately get your systems to be visible in Foreman. You can import your Puppet classes to Foreman automatically. All of that stuff happens. And a lot of people really like the fact that they see their setup very quickly in a web UI. Right. So let's see that. So just to try to fill the gap for those who are seeing the Puppet classes and stuff. So we have, sorry, not here. We have the ability to see all of the Puppet classes, and we can also import the Puppet classes. I guess that, yeah, okay. I don't have a lot to show here. Maybe I'll use someone else's Puppet master. And in here you can see that it gets all these classes. So this is someone else's environment. So basically it doesn't match to my environment. The Foreman tries to synchronize the list of packages. Quite a lot, hard to see, but basically it gets all of your existing environment, existing setup, and just update Foreman with that information. There's a lot of screens here. I don't know if we should go over all of them, but basically we have stuff here to manage the host groups themselves, to manage the classes. We have a notion of smart variables. That's how we solve the port and the value that that machine is supposed to be getting. So, for example, in my Apache class, I want to define how to. Here's a very simple example for a port. Default would be 80, and I decided I want to allow only 80, 80, 80, and 8123. So I can create all kinds of combinations. This is actually a bit complicated. I don't want to get into it, but it allows you to create custom matchers saying if this machine is located in domain X or in that environment with that host group or a combination, give it this value. So it's kind of a hierarchical way to get the right value for the right system. Besides that, we have the definition here of proxies. And proxies can have all kinds of features like DNS or CA or things like that, and we can import, for example, I could import subnets. So I guess this already imported, so I don't have anything new, but if I'll choose, in this case, I'll choose a Windows server running DHCP, so our proxy can run also on Windows. A proxy is actually a Sinatra app, Ruby Sinatra app, that can run even on Windows. And obviously, sadly, it's a bit slower, and they have lots of subnets. But here we can see all of their subnets that we could choose to import and put the attributes and provision and so on. Maybe worth also seeing is the compute resources. This is where we define over EC2 and so on. So, for example, for the overt server, I have here that at the moment I could just maybe view the information about the virtual machines, power them on, or I don't know, do stuff with systems. If it's EC2, it looks a bit different, but roughly the same kind of idea, where we can see the virtual machines as well. That I should probably destroy once we finish this presentation. And also images. At the moment, I just defined one AMI that I want to allow to use in this case. And we have all kinds of, maybe worth seeing again, another thing worth seeing is how we, basically how we kickstart, or how we do this. At the end of the day, to do a provisioning, you need either some shell script or pre-formatted in the right way, some sort of a text input usually to be able to trigger. So, for example, I guess most of you would know how a kickstart looks like. So in here we have an editor, basically allowing us to, this would be a kickstart template. It will be a Ruby embedded template that you could, substitute values and so on, based on variables, based on conditions, like you can do in any other ERB. And just for fun, I'll change some things here. You could see here eventually what it does. It will just synchronize clocks, maybe register the system to RHN if it makes sense, and do yum install Puppet, for example. I think that's more or less what it does. This gets compiled or converted, not compiled, into a real representation of a kickstart that later on is consumed by the system. And of course, you could see the diff view of what I just changed, so help you see what was done. We actually we had a lot of inspiration from GitHub, so it was really nice to use their same editor and stuff like that. And you could also obviously see the history of this, so this kind of changes are very important to keep history and auditing. Maybe about the templates, you could see also, you can see them here when you look at the system, and you can see the generated output eventually for Kickstart. This is something that is actually consumed by the system. And it's not just Kickstart, we have templates for all kinds of stuff. It could be all of the PXE related or gPXE, if anyone knows that. It could be for scripts that you can use whatever. A lot of people don't reprovision completely, they just do, they fetch the kernel, put it, reconfigure, grab and reboot the machine so they don't have to, similar to how Anaconda does updates. So you could basically do that and use all kinds of, do whatever you want with this kind of framework for things like that. Yeah.
Does it make sense to allow users to edit Puppet manifests themselves in that cool in MyManager?
Well, normally people like to keep Puppet manifests themselves in version control. So I don't know if it makes sense, to be honest. A lot of people are interested in being able to see the Puppet manifest in the UI. A lot of people could be interested in getting a lint equivalent of Puppet manifest in the UI, show you whether your Puppet code is, valid and so on. I'm not sure if you want to add anything here. Kind of mixed feeling, because usually the change of Puppet code should go through a very strict change management process. You know, if you care about those things. Great. What else do we have? Okay, so as I mentioned, we have an API. We have a really powerful search API. I think I mentioned we have a CLI, and now we're working on a much better version. There's a mobile app for Foreman that runs on iPhone, Android, and some and friends called Remote Admin, done by the community, someone from the community. In terms of user management, we do LDAP, Active Directory, and internal authentication. We have a very enhanced or very good, I think, RBAC model, so you could define all kinds of filters and definitions, which conditions can a user provision or view or whatever the information in Foreman. We have also the ability to group and nest groups, so you can put groups inside groups. And a lot of people are using Foreman in a kind of crude self-service portal. So they allow access to their managers only to see some parts. I don't know, things like that. Besides that, we have a Foreman installer. The installer is written in Puppet, so make it very easy for those who already use Puppet to contribute to the installer, which can take care, obviously, of Foreman itself and the proxies, but it also can build you up a full Puppet master environment. So if you're just starting with Puppet, you want to try it out, the installer can do all of everything for you. It can even configure Git and use Git branches as Puppet environments, fully automated that you can just, play and get the whole setup running, hopefully in a few minutes time to get it all automated. But the project, roughly 3 years old tomorrow, currently 60 plus contributors. I think 50 of them are at least non-Red Hat contributors. I know of about 5,000 installations, but most of the people who end up installing Foreman would be large-scale enterprises that are looking for those workflow and looking for the visibility of, their configuration management infrastructure. There's some links here, just to give you a feeling. Some of the users, things like CERN or Norton, Symantec, BBC, I don't know, all kinds of companies using Foreman. These are the ones that put themselves in the wiki. There's plenty more. Mostly important, our community is friendly. We like patches, but we also happy to help users and newcomers. We have an IRC and we have mailing lists, and I got links if someone wants to. And that was a good time to ask more questions.
Can you have more Windows installations?
You can to some degree, but not as simple as Linux, because Windows doesn't really support that without paying for the RIS, remote installation service. You can, users have done that, but you need to create an image which loads minimal Windows OS that later on goes and asks Foreman for content and configure itself. But you can, and I didn't show that, have Windows here. So assuming Puppet runs on Windows. And you can see here in the bottom, I have a Windows machine. It works really the same way that any Linux machine works. It has facts, just exactly the same way Windows has facts. Maybe not as extensive, but I don't know if there are any interesting facts, but really the same concept applies for Windows. So you can see the wrong kind of slash, and things like that. So it works just the same.
Can you connect to its console?
Sorry?
Can you connect to its console?
Windows? Yeah, I should be able. So one of the things, I think I installed it. Let's see. I think I created that VM manually, not through Foreman, so you don't see the console. So you don't see the console. one, but you could reach the console kind of if you know how to reach it. You could see the VM. Seeing it run the liquid. I think it's on one of this. Let's see. No, probably the other one. But yeah, you could. I didn't create the link in the UI, but Active Directory. This guy. There's no link, but if I just add /console. Okay. It's either spice or not configured correctly. So there's a special setting that you need to. I think I created a thread manager which makes VNC listen on loopback only. So that doesn't work. But normally you could use Windows. You could see Windows. No VNC works just as it's a VNC. Yes.
What are you using as a search engine?
We use a gem that the guy behind you wrote, Amos. Yeah. We took an existing gem that had search functionality that started as text, and he added the autocompleter part. You might recognize that the search is very similar to RevM kind of idea, which was written by the same guy who sits behind you. Basically, the idea is to make a text entry. People like CLI, so try to come up with a similar CLI manner for searching. But it also simplifies the API a lot, because you just need to get a search string, pass it to the CLI as an attribute, and you get the result. I don't need to create all kinds of filters on the API layer, search by name, search by environment, search by that. It's just a string you get, pass it, and process it. The gem called scope search you can use, but it relies on active record, so it fits exactly to your needs.
You had a web page which showed a list of facts and the values. Do you show the historic changes of those values?
No, currently not. It's not supported yet. It's something that we would like to do. It's simply we need to find a good data store to keep them well. It's a lot of data, so we didn't do it yet. But it's something on our agenda.
So what data store do you use currently?
We currently support, MySQL, Postgres, SQLite, whatever. But in order to keep them historically, we just need to redo it. It's not a big deal. The current data store that we store for facts is not good enough to store also historical changes. But we plan on adding other configuration management platforms like Chef to foreman. So it doesn't really matter which kind of configuration management you use. And therefore we'll probably do it in that refactoring as well. Yeah.
To be honest, I'm a bit confused because Foreman has our database, our web user interface, our authentication mechanisms, our role-based access controls, on everything. And I have heard some rumors that it should be integrated to Catalog with the System Engine 2.2.
Yeah.
And my question is how we ensure some consistency between either web UI or more between databases, because you can have different role-based access settings on Foreman and on Catalog, and this will play in.
Okay. So first of all, it's a good question. What we're doing now is basically integrating Foreman into System Engine. We are now evaluating what are the right ways to integrate, but if we follow the same model that we integrated Pulp and Candlepin, for example, into System Engine, then the Arbor probably will be on a higher level in Catalog, and we'll ignore Foreman's Arbor for that matter. So the users will be administrators and the permissions. It depends which permission model we take. If we extract the permissions service to the permissions into a separate service, it's a different implementation. So this is one of the things that's one of the reasons why we're here, to to get together and discuss those things. But Foreman exists as a community project before Catello started, and it's very important for Foreman to have those kind of features. So that's why they exist.
Well, I feel like a lot of features overlaps.
Yeah.
Like Puppet integration or stuff
Well,
like
Puppet integration will happen through Foreman. Catello will drive Foreman's API, and we'll get the reports and all of that stuff. So Catello is orchestration above all of those tools, or fetching the data from them and managing them in a common UI that gives you subscriptions, gives you content, and gives you control over Puppet and provisioning. So there are overlapping things, and we do try to extract common logic into gems when it makes sense, so they can be used across project and maintained as one unit. There's a lot of stuff that, for example, our orchestration layer that triggers basically goes to, when we created an instance in EC2, I created a DNS entry in one server, I created the EC2 on another server, I did a lot of things on multiple backend services. So all that code, for example, is shared and eventually should be extracted into a plugin or a gem. The search was done the same way, things like that. So we try to share as much as we can.
Just small information. Did you try to run on JRuby as well?
Not that much. So Foreman is really community driven, and it's really system administration driven, meaning that they want it to work with stock RHEL or stock CentOS. They usually don't care about Fedora because it's not stable. You don't want to run things in production with Fedora. So if there is a package for Ruby and there's no package for JRuby, then they don't want to try JRuby normally. Performance-wise, we had good experience with Ruby. Could be much better with JRuby, I agree. But it's kind of, so Foreman at the moment is mostly a subset of Puppet community. So Puppet community runs Ruby, not JRuby, so that's kind of the flow of things.
Thank you.
Let's assume I don't care about provisioning. Let's assume I have a machine that I want somehow to see here. I want to see the facts. I want. How do I
So actually
register it? How do I
Foreman
connect it?
works in multiple modes. You could turn off provisioning completely, and you'll see completely different set of screens, or much smaller sets of screens, much smaller sets of options to choose from. And if you have a Puppet client running, it produces all kind of metadata that Foreman can import. So you could simply configure a very simple Puppet infrastructure and interconnect that with Foreman, and a lot of people actually just using Foreman for the dashboard and reporting and fact browsing. They don't want provisioning and they don't care, and they just use it just as is. So you could definitely do that.
Okay. Well, what if I don't have the Puppet client running?
So you would need to install the factor RPM, so you get the facts, and there you could hit the URL on Foreman to upload those facts, and it will be shown in the web UI. So like a one-liner with curl to the right URL in Foreman, and you'll see the data.
I'm running the stable 0.4
Yeah.
Foreman. If I upgrade YAM update to the 1.0, can I expect some smooth transition, or is it
Ideally, yes.
supported? All
Yeah.
right.
We passed release candidate 3. We probably would have released if I wasn't here this week, so it's bad practice to release while you're on business trip. And I think you should be able, there's a major difference is that now there are like 30 or 40 RPMs instead of one, because every gem gets its own RPM. We actually package Rails itself. Because it's not in CentOS or RHEL do not provide RHEL as it by itself. We do make sure to be on the same stack like other system engine components, but there's lots of gems now, or RPMs that you install. We also broke down, you could say I want to install Foreman with Libvirt support, or Foreman with Postgres support. It's all broken down so into meta RPMs that you can choose the right functionality that you need. Like this database adapter, and I only care about Ogre, I don't care about EC2. Something like that. Cool. the main reason to use Fog was because it was not a service, and that it provides Ruby objects that you could simply consume. The amount of code to handle Fog, those of you who don't know, Fog is, you can assume by its name, it's something with the cloud. It's a library, a Ruby library for managing, I think, about 20 to 30 different cloud providers that exist today. So it's a very extensive library, not always perfect quality, but for the important things like overt, libvirt, EC2, things like that that are important. They have very good code coverage. It provides really good objects that you can really consume without a lot of effort. That's why we chose it. I'm not saying that Delta Cloud is any bad, or there's no strategical decision not to use Delta Cloud, but it's much faster to get running and without any effort.
So the main reason was Fog is a library, Delta Cloud is a REST service, right?
Yeah, so the main reason was not to force the users to start another daemon and put their credentials in another place, and in terms of flow, in terms of complexity.
So like we released like a week ago a new version 1.0 and there's a library separate. So
That
used to be Delta.
That would be really interesting. I don't know how's the coverage of Fog and versus Delta Cloud, so like OpenStack or other things that are now Google Compute or other things that are now getting popular. But if we can do it, why not? I mean, the main benefit for Fog is the amount of contributors it has. Like, amazing. I don't know how many, 500 contributors plus. Every feature in EC2, a day after it's released, you already see the patches, for IAM permissions or whatever. It's a really popular library. Saying that, we definitely want to support our own stuff. So, patches are what, kidding, but yeah. Probably can figure out the dual mode to work with both of them for a while.
Yeah, I will check like how you use Fog and I can figure out like what will be done
Yeah.
to use Delta Cloud. So I can send you a patch.
Okay, I think besides that, I mentioned most of the things here, so no need to repeat myself. Unless you have any more questions, yeah, go ahead.
Working with EC2, for example, is by definition asynchronous.
Yes.
You issue a command, you never know what happened.
Mm-hmm.
You basically need to pull back to get a status.
Right.
Which is what the Delta Cloud kind of handles. So, in the case of foreman and Fog thing, what is the part, or which part of the system does the polling so that you actually know whether the action that you scheduled actually
Yeah.
finished properly
So
or not?
foreman has an orchestration layer, which is wrapped around active records callbacks. Basically, we currently, at least the first implementation was done within the transaction of the instance that we deploy, and we have a mechanism to pull. Or Fog actually provides us a mechanism to pull, to do a busy wait kind of pooling on instances, status, or things like that. So we use that. We simply use that. So for example, we say create an instance, now wait until it has an IP address, and basically it does something like every second, or there's some algorithm to decide how often it goes and queries until you get the status. Thank you.